This is Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today our topic is vector integral theorems. In the vector integrals theorem, here three theorems are there. First one is Gauss Divergence Theorem. Okay. In the vector integral theorems, first one is Gauss Divergence Theorem. Gauss Divergence Theorem. And the second one is Green's Theorem. And the third one is Stokes' Theorem. These are the theorems under vector integral theorems. Okay, first one is Gauss divergence, second one is Green's theorem, and the third one is the Stokes' theorem. What are the uses of these three theorems? Means transformation between line to surface and volume integrals. Transformation between line, surface and volume integral. Okay, in that first one, okay, in the theorems, first one is the Gauss divergence theorem. What is the use of the Gauss divergence theorem? Means here transformation between surface integral and volume integral. Okay, first theorem uses transformation between surface integral and volume integral. What is surface integral? Double integral form. And what is volume integral? Triple integral form. Now I'll explain clearly on the statement here. What is the statement of the Gauss divergence theorem here? Let S be a closed surface enclosing a volume V. What is S here? One surface that is enclosing with a volume V. Here F bar is a continuously differentiable vector point function. What is F bar here? One vector that is passes through the surface here. That is vector form is continuously differentiable vector point function. For that case here the formula is integral V divergence of F bar dV is equal to what? Integral S F bar dot N bar ds. Okay, once you observe the theorem statement here, the formula here, that is integral V divergence of F bar dV is equal to integral S F bar dot N bar ds. That means volume integral. Volume integral is equal to what here? Volume integral is equal to surface integral. Okay, volume integral is here integral V divergence of F dV is equal to integral S F bar dot N bar ds. But what is N bar here? N bar is the normal vector. It passes through the outward drawn vector at any point of S. Okay, here N bar is the outward drawn normal vector at any point of S. This is the theorem statement of the Gauss divergence. Mainly use of this theorem is transformation between surface integral and volume integral. But from the theorem statement here, the formula is integral V divergence of F dV is equal to integral S F bar dot N bar ds. But here what is divergence of F bar? Divergence of F means what is the symbol of divergence? Already we discussed in the previous classes. Divergence of F bar is equal to what? That is a del symbol. Okay, del symbol. Okay, with the dot product with the vector point function, that is F bar. But what is del here? I bar into dou by dou x plus j bar into dou by dou y plus k bar into dou by dou z into what is F here? For vector, that is F1 I bar plus F2 j bar plus F3 k bar. Simply multiply, that means dot product with both the vectors here. How to product the both the vectors here means, once you observe here I bar coefficient is dou by dou x, here I bar coefficient is F1. That means here I bar is equal to how much? 1. And j bar is equal to 1. And k bar is equal to 1. That means here I bar coefficient is dou by dou x of F1. And the j bar coefficient is here dou by dou y. Here j bar coefficient is F2. That is dou by dou y of F2. Plus here what is k bar coefficient for the first vector? That is dou by dou z. Here k bar coefficient is F3. That means here dou F3 by dou z. Therefore, this is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. This is divergence of f bar. Okay, and what is f bar dot n bar? Okay, this is divergence of f bar from the RHS part of the formula here. Integral s f bar dot n bar ds is equal to surface integral on the three-dimensional space here. Here ds means xy axis and yz axis and zx axis. That means here f bar is one vector point function and that is product with n bar. What is n bar here? Unit normal vector, and ds means either xy plus yz plus zx form. Okay, that is f bar dot n bar ds. Okay, that means here integral double integral of f bar dot n bar into dx dy plus double integral of f bar dot n bar into dy dz plus double integral of f bar dot n bar into dz dx. Okay, this is integral s f bar dot n bar, that is double integral of f bar dot n bar dx dy and double integral of f bar dot n bar dy dz plus double integral of f bar dot n bar into dz dx. This is what we explained now. That means integral divergence of f bar is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. In that LHS part, here what is dv? dv is equal to what? dv is equal to dx dy dz. Okay, that means simply what we write here that is double integral, triple integral of volume integral means triple integral form of triple integral form of divergence of f bar means dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z into dx dy dz. That volume integral is equal to here what? That is equal to surface integral formula, that is triple integral of f bar dot n bar dx dy plus double integral of f bar dot n bar dy dz plus double integral of f bar dot n bar dz dz. Here normal vector is outward of the vector at any point of the S. I'll explain what is outward drawn normal vector at any point of S means. I'll explain that concept on the problems. Okay. Now I'll start with the first question from the Gauss Divergence Theorem. Okay. Solved problems. Verify Gauss Divergence Theorem for here what is f bar? F bar is equal to x cube minus yz into I bar minus 2x square y into j bar minus plus z into k bar taken over the surface of the cube bounded by the planes x is equal to y is equal to z is equal to a and the coordinate planes. Where we have to verify the Gauss Divergence Theorem, here the vector point function is here. F bar is equal to x cube minus yz into I bar minus 2x square y into j bar plus z into k bar. It passes through the surface of the cube. Okay, it passes through the surface of the cube bounded by the planes. What are the planes here? Here the planes are x is equal to y is equal to z is equal to a and the coordinate planes. Now I have to verify the given conditions on the Gauss Divergence Theorem. Already we know that what is the Gauss Divergence Theorem. Gauss Divergence Theorem mainly use of the transformation between volume to surface or surface to volume, right? Volume to surface or surface to volume. Okay, now what is the statement of that? Integral s f bar dot n bar ds is equal to integral v divergence of f bar dv. Okay, this is the formula for the Gauss Divergence Theorem. Now I have to verify LHS part and the RHS part from the given conditions in the question. If you are applying the conditions from the Gauss divergence, if both LHS and RHS are equal, then Gauss Divergence Theorem is verified. Okay. Okay, let us start with the Gauss divergence. This is the theorem statement, that is integral s f bar dot n bar ds is equal to integral v divergence of f bar dv. Okay. First, I'll start with the RHS part of the Gauss divergence theorem. What is the Gauss divergence? The RHS part here, integral V divergence of F bar dV. Right? But here the question, what is F bar? What is F bar? Once you see all of you, that is F bar is equal to x cube minus yz into I bar, x cube minus yz into I bar minus 2x square y j bar 2x square y j bar plus z k bar. Okay, this is the vector point function from the given question, that is f bar. Okay, then what is the RHS part for the theorem? Integral V divergence of f bar dv. First I'll calculate that part. Okay, here f bar is the given one, and what is divergence of f bar? Divergence of f bar means I bar into dou by dou x plus j bar into dou by dou y plus k bar into dou by dou z. Okay, divergence means del operator, that is I bar into dou by dou x plus j bar into dou by dou y plus k bar into dou by dou z. Dot product with f bar, that is x cube minus yz into I bar minus 2x square y j bar plus z into k bar. X cube minus yz into I bar minus 2x square y into j bar plus z into k bar. Now multiply both the vectors here. That is how to multiply here. The I bar coefficient is dou by dou x of, okay, that is here the I bar coefficient is x cube minus yz. Okay, x cube minus yz plus what is the j bar coefficient for the first vector? That is del operator, that is dou by of. Here the j bar coefficient is minus 2x square y plus here what is k bar coefficient? Dou by dou z. From the second, from the f bar here k bar coefficient as z. Okay, once you see after the dot product here I bar dot I bar is equal to 1, j bar dot j bar is equal to 1 and k bar dot k bar is equal to 1. Now differentiate the first part with respect to x. Dou by dou x of x cube minus yz means what here? X cube minus yz means with respect to x cube differentiation as 3x square minus what about the yz with respect to x? 0. Plus dou by dou y of, okay, dou by dou y of minus 2x square y. With respect to y, x square is constant and differentiate y, that is minus 2x square into y differentiation is 1 plus dou by dou z of z only here, that is 1. Therefore, that is equal to 3x square plus into minus minus 2x square plus 1. This is divergence of f bar. Okay, therefore that is divergence of f bar. And here, what is dv? dv means dx, dy, dz. Okay, that means integral v divergence of f bar dx, dy, dz. Here, but what is integral of mean? That is volume integral. That means triple integral form. But for the given question, what are the limit points here? What are the limit points here? The vector is passing through over the surface of the cube bounded by the planes. What are the planes here? X is equal to y is equal to z is equal to a. That means here cube is passes through, the points are x is equal to y is equal to z is equal to a. That means here what are the limit points from that? 0 to a, 0 to a and 0 to a. Directly I am calculating the volume integral. Okay, that is integral 0 to a, integral 0 to a, integral 0 to a, divergence of f bar dx, dy, dz is equal to here, that is triple integral of 0 to a, 0 to a, 0 to a. That is 3x square minus 2x square plus 1 into dx dy dz. That is, okay, once you observe here, 3x square minus 2x square is x square plus 1 into dx dy dz into dx dy dz. Okay, first integrate with respect to x. Okay, what is the integration with respect to x? That is, x square integration is x cube by 3, right? Plus 1 integration is x, and the limit points are 0 to a. Okay, and now substitute the limit points after the integration with respect to x, that is a cube by 3 plus a, right? And the lower limit is 0, that means that is 0 only. Okay, after substituting the x limits, now integrate with respect to y. Okay, integrate with respect to y. Okay, that is a cube by 3 plus a as constants with respect to y. That means here a cube by 3 plus a, and the y limits are, that is 1. 1 integration is here y, that limits are 0 to a. That is a cube by 3 plus a, y limits are 0 to a, just substitute here, that is a. Okay, first substitute the upper limit, we got a, and lower limit is 0. After the x integration and after the y integration, here we got a cube by 3 plus a into a, and the next integration with respect to z, and the limit points are 0 to a. With respect to a, z means remaining all is constant, and here with respect to dz, that is 1. Okay, that means here a cube by 3 plus a into a integral dz, that means z. What are the limit points for that? 0 to a. That is a cube by 3 plus a into, after substituting the z limit here, a minus 0. That is a cube by 3 plus a, that is a square. That is equal to what? A power 5 by 3 plus a cube. Okay, let us take this as the first equation. Let's take this as the first equation. From the Gauss Divergence Theorem, first I'll calculate the RHS part, that is the volume integral formula, that is integral V, divergence of F bar dV, value how much? A power 5 by 3 plus A cube. Okay, next. From the Gauss Divergence Theorem, RHS part over. Now I'll continue the verification with the LHS part. Here from the Gauss Divergence Theorem, what is LHS part? LHS part as integral S F bar dot N bar ds. Okay, here once again, here what is the question? F bar is taken over the surface of the cube bounded by the planes. Here the vector is passes through over the surface of the cube bounded by the planes. That means once you observe here, we will calculate the value of surface integral over the cube. Cube means how many faces here? 6 faces, right? Here cube means 6 faces. Through the diagram only, now we have to calculate the surface integral. Before that, before RHS part directly we got the answer, but the LHS part from the diagram only we got the answers for the surface integral formula. That is here cube. Cube means how many faces? 6 faces. Let us draw the diagram here. Here the 3-dimensional space, okay, this is the cube, okay, here the x and y axis and z axis, right? Okay, here what are the steps for that? Over the 6 faces. 6 faces means, okay, surface integral S f bar dot n bar ds is equal to, okay, now I'll calculate the, okay, that is calculate the surface integral on the first phase. What about the first phase here? S1 into f bar dot n bar ds plus integral S2 f bar dot n bar ds plus integral S3 f bar dot n bar ds plus integral S4 f bar dot n bar ds plus integral S phi f bar dot n bar ds plus integral S6 f bar dot n bar ds. That means we have to calculate the surface integral on cube of the 6 faces. Okay, that is first one is the S1 face, and the second one is the second face of the cube, and the third face S3, and the fourth face S4, and S5 and S6. Okay, that's the 6 faces of the surface cube. That is for here S1. What is S1 here? Once you see here from the cube, what is the first face here? That is S1 is equal to PQAS. S1 means what? PQAS. Okay, that means from the cube here on the three-dimensional space here, that three-dimensional space here on x-axis 2 faces, y-axis 2 faces, and the z-axis is 2 faces. That means here S1 is equal to PQAS. From that, outward unit normal vector is what? PQAS means this is PQAS, that outward unit normal vector as I bar. Okay, and next one here, second face on x-axis, that is OCRB. Okay, second face on the cube is on OCRB. That is also an x-axis, that is OCRB. That unit normal vector as minus I bar. N bar is equal to minus I bar. There n bar is equal to I bar on S1. Positive direction, S2 is a negative direction. From that, let us take n bar is minus I bar. And from the next phase, S3 is equal to, okay, S3 is equal to what? RBQP. 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 Which axis this is on? Z-axis. Z-axis, this is Z-axis, this is the positive direction or negative direction? This is in positive direction. That is here Q, B, R, P. Okay, Q, B, R, P. That unit normal vector here, n bar is equal to k bar. N bar is equal to k bar. What about the next phase on the cube on z-axis? Okay, here n bar is k bar, means this is on z-axis. And next S4. Fourth phase here. What is the fourth phase? OACS. OACS. That is on the fourth phase of the cube. That is OACS. OACS. That is on z-axis, negative side, that is n bar is equal to there minus k bar. N bar is equal to minus k bar. And what about the fifth phase here? Fifth phase on x-axis 2 faces over, on z-axis 2 faces over. Now I'll calculate on y-axis. What is y-axis here? S5. S5 is PSCR. S5 is PSCR. Okay, this is y-axis first phase, that is S5. PSCR, that unit normal vector as J bar. S5 is PSCR, that unit normal vector as J bar. And the last phase of the cube, that is S6, OBQA. OBQA, that is S6 is equal to OBQA, that unit normal vector on left negative direction, that is minus J bar. Okay, these are the 6 phases. Now we have to calculate each and every value on S1 phase, S2 phase, S3 phase, S4 phase, and S5 and S6. After adding that all values, we got the surface integral value. Okay, that surface integral value is equal to the RHS value. What is RHS? Volume integral value. If both the values are equal, then the Gauss Divergence Theorem is verified for the question. Okay, now I'll start with the verification for the first phase S1, that is PQAS. That is PQAS. Okay, that is S1 is equal to PQAS, that is on x-axis. PQS and x-axis, that outward unit normal vector as I bar. Why? Because here why you are taken n bar is equal to I bar, that is the positive direction on x-axis, that way you can consider the outward drawn vector as n bar is equal to I bar. But what about the x point here? What about the x point here? X point is passing through x is equal to 0 to a. Here x is equal to 0 to a. Now we are calculating on the positive direction of the x-axis. That's why I'll consider x is equal to a. And what about ds? What about ds? ds is equal to dy dz. Okay, here it is on x-axis. A means that ds is equal to what? Dy dz. Okay, therefore here what about the y and z points? Y limit and z limits here 0 to a and 0 to a. Y limit points are 0 to a and z limit points are 0 to a. But here what is ds means what? Generally we know that ds is equal to, we have to discuss this is in the surface integral, that is ds is equal to dy dz by modulus of n bar dot I bar. Already we know that here n bar is equal to I bar. That's why here ds is equal to what? Dy dz by n bar is I bar dot I bar. That is dy dz by 1. That's why directly here I am writing ds as dy dz and x is equal to a and ds is dy dz and y limit starts from 0 to a and z limit passes through 0 to a. Okay, therefore that is this one. Okay, now we have to calculate the surface integral on the first phase S1. Therefore double integral of S1 into f bar dot n bar. Okay, what is f bar dot n bar here? F bar is the given vector and n bar is the unit normal vector. That is, what is f bar in the given question? That is x cube minus yz into x cube minus yz into I bar minus 2x square y j bar plus z k bar. This is f bar vector and n bar is unit normal vector, that is I bar. Okay, that is I bar. Therefore, multiplying both the matrix, that is x cube. Once you see here n bar is only I bar, then you have to multiply I bar coefficient for the first vector and the second vector directly I bar. Therefore, the first vector I bar coefficient is x cube minus yz and the I bar coefficient is 1, that is x cube minus yz. That is f bar dot n bar. But here from the question conditions here, for the first condition, x is equal to a, x is equal to how much? A. Now substitute here, that is a cube minus yz. Why? Because here x is equal to a, that is a cube minus yz since x is equal to a. Therefore double integral of f bar dot n bar ds is equal to, that is a cube minus yz into dy dz double integral. And what are the limit points for on yz? With respect to yz, you have to integrate, means here the y limits are 0 to a and z limits are 0 to a. Y limits are 0 to a and z limits are 0 to a. First integrate with respect to y and after that integrate with respect to z. Okay, that is this one here. On the next slide. Okay, that is integral with respect to y integration, that is a cube y minus y square by 2 into z. With respect to y integration this is, and what are the limit points for the y? 0 to a and into dz. That is, here substitute the y limit points, that is integral z is equal to 0 to a cube a minus a square by 2 into z minus of y points up lower limit is 0 into dz. That is integral z is equal to 0 to a power 4 minus a square by 2 into z dz. A power 4 minus a square by 2 into z dz. Now integrate with respect to z. that is a power 4 with respect to z means a power 4 is constant and 1 integration is z minus a square by 2 into z integration is z square by 2. Limit points z is equal to 0 to a. Then substitute here a power 4 upper limit as a minus a square by 2 into z square by 2 means a square by 2. Okay. Then substitute the lower limit, that is after substituting the lower limit completely, that as 0. Therefore, a power 4 into a as a power 5 minus a power 4 by 4. This is this one. Okay. On S1 surface, the integral S1 f bar dot n bar ds value how much? A power 5 minus a power 4 by 4. Let us take that as the second equation. On S2 phase, what is S2? Already I discussed. S2 phase on x-axis negative direction, that is OCRP. OCRP. That unit outward normal vector as n bar is equal to minus I bar. Okay, left side, that is on negative axis, x value is how much there? It passes through 0 to a. That means x value there 0. On x-axis, negative side, x value is 0. That ds is dy dz. Okay, then ds is dy dz means that limit points for y is 0 to a and z limit points are 0 to a. Okay, now we have to calculate an S2 surface integral value, that is double into S2 f bar dot n bar ds is equal to here what? Double integral of f bar dot n bar into ds means what here? Dy dz by modulus of n bar dot minus I bar. Why? Because unit normal vector is I bar. That is double integral of f bar dot n bar into dy dz by modulus of n bar means here how much? This is why here plus I bar. Here n bar means substitute negative value. That is minus I bar dot I bar. That is double integral of f bar dot n bar into dy dz by I bar dot I bar 1 modulus means that is plus only. So dy dz by 1. Therefore, double integral of f bar dot n bar into dy dz. Okay, now integration with respect to y and z means now we can take y and z limit points. That is y is 0 to a and z limit points are 0 to a. That is double integral of y is 0 to a and z is 0 to a f bar dot n bar into dy dz. Now integrate with respect to y and z. First we have to calculate f bar dot n bar. Here what is f bar? From the given question, f bar is here. If you are multiplying with n bar means directly here we got minus of x cube minus yz. Okay, minus of x cube minus yz, that is here x is 0. X is 0 means here you can substitute in place of x as 0. Therefore, minus, that is 0, minus into minus as plus, that is yz. Therefore, f bar dot n bar is equal to here how much? Yz. Therefore, double integral of f bar dot n bar ds is equal to here double integral of z limits are 0 to a and y limits 0 to a yz dy dz. Yz dy dz. Now first integrate with respect to y. Okay, that is y integration is y square by 2. Limit points y is 0 to a z dz integral z to 0 to a. Now after the integration of y, now substitute the y limit points, that is y square. That means upper limit point as a, substitute there, that is a square by 2, lower limit as 0. Directly we got here a square by 2 and after substituting the limits, now we integrate with respect to z. What is the integration with respect to z? Z integration as z square by 2. Now I will write that step here. A square by 2 integral z is equal to 0 to a z dz, that is equal to a square by 2. Z integration is z square by 2. Limits are 0 to a. That is a square by 2. Okay, upper limit is a square by 2 minus 0. That is a power 4 by 4. Therefore, from the surface integral value on S2 phase, that is equal to a power 4 by 4. Okay, let us take that as the third equation. Let us take that as the third equation. Next, only two phases are over. Next, surface integral on S3 phase. What is S3 phase? Here I'll take S3 phase as RBQP. RBQP. It is on Z-axis, that limit point as A. It is at Z-axis, that limit point as A, and that ds is equal to dx dy. Okay, and the unit normal vector, outward unit normal vector as Z-axis positive direction, that's why I'll consider n bar is equal to k bar. Okay, there here ds is dx dy means here the x limit points are 0 to A and y limit points are 0 to A. And after that multiply f bar dot n bar. Okay, f bar dot n bar means here directly z. Okay, what is f bar? Here f bar means x cube minus yz into I bar minus 2x square y into j bar plus z into k bar. Right? Same question. Plus z into k bar. Into n bar means here what? K bar. This is f bar dot n bar. Multiply both the matrix for the f bar dot n, that is z. K bar coefficient is z and here k bar coefficient is 1. That is f bar dot n bar is equal to z. But from the condition here z is equal to how much? Here z is equal to a. Then substitute here f bar dot n bar is equal to a. Okay, this is the condition. Therefore, here f bar dot n bar is equal to how much? A. Therefore, the surface integral of double integral of S3 f bar dot n bar ds is equal to y limits from y is 0 to A and integration of x is 0 to A. F bar dot n bar is A into dx dy. First integrate with respect to x, that is A into A, that is A square. And after that integration with respect to y, that is y a square into, after substituting the y limit here, a square into a as, that is a cube. Okay, therefore the third phase surface integral value as a cube. Let us take that as the third equation. Let us take that as the third equation. Next, surface integral on S4 phase. S4. What is S4 here? OASC. OASC on the cube. Okay, there z is equal to 0. Why you have taken z is 0? Here OASC on z axis negative direction. Negative direction. From that limit point as 0, that unit normal vector as negative, that is minus k bar. N bar is equal to minus k bar. That ds is equal to here. What is ds here? Dx dy by modulus of n bar dot k bar. But here dx dy by modulus of, that is minus k bar dot k bar, that is dx dy by 1. Therefore ds is equal to how much here? ds is equal to dx dy. Here x limit points are 0 to a and y limit points are 0 to a. Therefore f bar dot n bar. Okay, again dot product with f bar dot n bar. Here n bar is equal to minus k bar. They're multiplying both the matrix here. Directly we got minus z bar. But from the fourth phase, what is z value? Z is equal to 0. Therefore, f bar dot n bar, if we are substituting z is equal to 0, f bar dot n bar is equal to how much? 0. Therefore, surface integral on the fourth phase, that is double integral of f bar dot n bar ds is equal to how much? Directly 0. Okay, let us take that as the fifth equation. Next. Okay, surface integral on the fifth phase. Okay, on x-axis 2 phases over and the y-axis over. Next, x-axis over and z-axis over, right? Next, I'll calculate the surface integral on y-axis. That is S5 phase. What is S5 here? PSCR. Okay, PSCR. From that, PSCR is in the positive way of the cube. On S5, that is y is equal to how much there? Y is equal to, the limit point is A. That unit normal vector there, n bar is equal to j bar. N bar is equal to j bar. From that, what is ds? What is ds? ds is equal to dz dx. Okay, ds is equal to dz dx, and the x is 0 to a, and z limit points also 0 to a. Then multiply here f bar dot n bar, product of the f bar and n bar. After the product of the two, directly we got here minus 2x square y, minus 2x square y, that is equal to here, just substitute here what is y value, a. In place of y, just substitute there, that is minus 2a x square, minus 2a x square. Why? Because here y is equal to a. Therefore here f bar dot n bar is equal to minus 2a x square. Just substitute here, that is on S5 phase, double integral of S5 f bar dot n bar ds is equal to, already we know that f bar dot n bar is minus 2a x square, and the x limit points are 0 to a, and the z limit points are 0 to a, and ds is here dz dx. Okay, now integrate first with respect to z. Okay, first integration with respect to z, that is minus 2a x square with respect to z means there one integration as z, that limit points are 0 to a, and the remaining is here integral 0 to a dx. That is minus 2a x square, z limit point as upper limit point as a, minus 0 into dx. That is x is equal to 0 to a, that is equal to minus 2a x square a. Okay, and the next integration with respect to x, with respect to x, that is minus 2a square, x square integration as x cube by 3, x square integration as x cube by 3, that limit points are 0 to a, that is minus 2a square into, okay, upper limit for the x minus a cube by 3 minus 0, that is equal to minus 2 into a power 5 by 3. Okay, that is this one. Let us assume that as the sixth equation. That as the sixth equation. Next, last phase on the y-axis, that is the negative side of the y, that is S6 is equal to OBQA. S6 is equal to OBQA. For that, y point is 0 and the unit normal vector as the negative direction, that is minus j bar, and are equal to minus j bar, and ds is equal to dz dx. ds is equal to dz dx. Therefore, then z limit points are 0 to a, and x limit points are 0 to a. Okay, dz dx here, dz x limits are 0 to a, and z limit points are 0 to a. Already we know that f bar dot n bar from the previous phase, that is f bar dot n bar is equal to there 2x square y, but here y is 0. That's why directly f bar dot n bar is equal to how much? 0. Therefore, double integral of S6 phase, surface integral of f bar dot n bar ds is equal to how much? 0. Okay, 0. Let us take this as seventh equation. This one is seventh equation. Therefore, add all the values. Okay, therefore add all the values, that is double integral of f bar dot n bar ds is equal to double integral of s1 plus double integral of s2 plus double integral of s3 plus double integral of s4, s5 and s6. Already we know that what is s1 here. S1 is equal to a power 5 minus a power 4 by 4. On S2 phase, minus a power 4 by 4. On S3, a cube. On S4, 0. On S5, minus 2a power 5 by 3 plus 0 is S6. Add all the values, therefore directly we got the answer from that here. Okay, here anyone is cancelled? No. Then okay, directly we got the answer after adding all the values here, that is a power 5 by 3 plus a cube. A power 5 by 3 plus a cube. Once you observe that answer, a power 5 by 3 plus a cube. Once you observe that answer is equal to what? Okay, that answer is equal to volume integral for the first equation. Therefore, here if both the values are equal, therefore the given question Gauss divergence theorem is verified for the given question. That means integral s f bar dot n bar ds is equal to integral v divergence of f bar dv, that is a power 5 by 3 plus a cube is equal to a power 5 by 3 plus a cube. Therefore, from the given question that a vector point function is passes through over the surface of the cube, for that case Gauss divergence theorem is verified. This is procedure for the verification of the Gauss divergence theorem. Next class we will discuss some other related questions on this topic. Thank you. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.